Take a slow breath and notice how ordinary it feels. For the next few moments, imagine that every oxygen atom on Earth simply vanishes. Not only the oxygen gas floating in the atmosphere, but oxygen locked inside water, stone, metal, and living cells. 5 seconds later, every missing atom returns to the exact planet it left. 5 seconds is too short for a healthy person to suffocate, but breathing would be the least important thing happening to you. This would be the most violent 5 seconds our planet had ever experienced, and the first sign would appear above your head. Before the countdown begins, one scientific warning matters. Removing all oxygen atoms is physically impossible, so this is a deliberately extreme thought experiment. Normal chemistry cannot describe matter while one of its major elements is temporarily deleted. The exact energies and motions cannot be calculated as if this were an ordinary reaction. What follows is a visual interpretation of scale, structure, and consequence. The important idea is that oxygen is not merely something around the planet. Oxygen is one of the materials from which the planet itself is built. Second, the familiar blue sky begins to lose its color. Earth's sky looks blue because sunlight is scattered by molecules in the atmosphere. Oxygen molecules make up about 21% of the air by volume. When that atmospheric oxygen disappears, the air becomes dramatically thinner in an instant. The sky would not become perfectly black because nitrogen and other gases would remain, but daylight would look darker, harsher, and deeply unfamiliar. The sun would appear more severe against a dimmer and less saturated sky. Blue oceans below would simultaneously begin losing the substance that gives them mass. Across every city, outdoor light would change before anyone understood why. Cameras would brighten automatically, making the sudden darkness flicker across billions of screens. Then pressure would deliver the second warning. The loss of atmospheric oxygen would remove roughly 1/5 of the surrounding air pressure. The pressure change would race through streets, rooms, aircraft cabins, and underground tunnels. Your ears would pop violently as trapped air tried to equalize. Some people could suffer painful damage, especially with blocked ears or sealed spaces. Windows would flex as indoor and outdoor pressure shifted at different speeds. Loose objects would jump, doors would slam, and dust would surge through cracks. The world would hear a vast sequence of cracks, bangs, and rushing air. It would not be one single explosion, but millions of pressure events arriving almost together. Before the sound finished traveling, the solid world would begin to fail. The countdown would already be moving into its second second. Second, look at the concrete beneath a modern city. Concrete contains minerals rich in oxygen, including silicates, aluminates, and water-bearing compounds. Remove the oxygen atoms, and those chemical structures no longer describe concrete at all. Pillars would lose the bonds that allow them to carry weight. Road surfaces would fragment beneath moving vehicles. Bridge decks would cease behaving like coherent slabs. Dams would lose the rigid material holding back entire reservoirs. Skyscrapers would not topple neatly in the way demolition footage teaches us to expect. Their mineral skeletons would disintegrate while steel frames twisted inside a collapsing cloud. From a distance, cities might appear to sink into their own foundations. The disaster would spread through buildings faster than gravity could complete the fall. And beneath those collapsing cities, the same transformation would be reaching the ground itself. Second, now turn toward the ocean. A water molecule contains 2 hydrogen atoms and 1 oxygen atom. By mass, oxygen accounts for almost 89% of ordinary water. Delete that oxygen and the substance we call water can no longer exist. The oceans would lose most of their mass without having time to flow anywhere. Coastlines would race outward as seabeds emerged across the planet. Ships would drop onto mud, rock, and collapsing marine sediments. Clouds would lose their droplets and ice crystals at the same moment. Rivers, lakes, glaciers, and groundwater would undergo the same impossible transformation. The remaining hydrogen would be extraordinarily light and chemically unstable in this new world. It could rush upward, expand, and mix with the gases still surrounding Earth. From orbit, the blue planet would begin turning brown, gray, and exposed. And the ocean would not be the only reservoir of water disappearing. Much of the human body is water, and oxygen is also present in proteins, bones, and DNA. There would be no meaningful biological version of you left to experience the next second. Fourth second, the world of machines would become strangely silent. Many metals are protected by microscopic oxide layers formed through contact with oxygen. Without those layers, clean metal surfaces pressed together can form direct metallic bonds. In vacuum engineering, this phenomenon is known as cold welding. Bearings, gears, valves, and electrical contacts could seize in unpredictable ways. At the same time, every ordinary flame would go dark because combustion requires an oxidizer. Car engines would stop producing power even before collapsing roads destroyed them. Jet engines would flame out, leaving aircraft to trade altitude for speed. Rocket exhaust, furnaces, power stations, and emergency generators would all be affected differently, but catastrophically. There would be almost no functioning infrastructure left to witness the fifth second. Fifth second, oxygen is the most abundant element in Earth's crust by mass. It accounts for roughly 46% of the crust because it is built into common minerals. Quartz, feldspar, clay, and countless other rocks depend on oxygen-bearing structures. Mountains would lose the chemistry that makes their minerals stable. Soil would cease to be soil, and the upper crust would become an alien mixture of remaining elements. The surface would fracture, settle, and release unimaginable quantities of heat and debris. The planet would not shrink by a simple, predictable number because its interior would be far from equilibrium. But the stable world we recognize would already be gone. Then the 5 seconds end, and every oxygen atom returns. Returning matter to a planet that has moved, collapsed, and mixed cannot restore the original structures. Atoms would appear inside debris, gases, exposed interiors, and spaces that no longer match their former positions. Violent recombination, pressure waves, and heating would sweep through the ruined planet. The atmosphere would rebound, but there would be no intact biosphere waiting beneath it. After the final shock waves faded, Earth would continue orbiting the sun in silence. We usually think of oxygen as one ingredient in the air. In reality, it is part of the sea, the continents, the atmosphere, and every complex organism we know. About 2.4 billion years ago, microorganisms began transforming Earth through oxygenic photosynthesis. That great oxidation event was toxic to many existing organisms, yet it opened the path toward our world. The next documentary will tell the story of how oxygen first became a planetary catastrophe, and then our greatest opportunity.